أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم، والصلاة والسلام على أشرف الخلق والمرسلين محمد وآله الطيبين الطاهرين. طلبة المرحلة الخامسة كلية الصيدلة جامعة بعنوان، السلام عليكم ورحمة الله وبركاته. هذا الكورس إن شاء الله اللي عندكم إياه هو Adv.chem عن طريق دكتورة الأستاذ المساعد دكتورة ساجدة منادي. الكورس مالتنا طلاب يخص السبكتروسكوبي عند بعض التكنيشن المتابعة للسبكتروسكوبي such as the UV, IR, البروتون NMR, الكربون 13 NMR and الماس spectrum. In general, the spectroscopy is the study of interaction between the electromagnetic ray and molecules or atoms, and this interaction will be occurred by two types, either absorption or emission spectroscopy. In absorption, when the molecule will be absorbed the ray and technician. This type will be included in UV, IR, NMR, colorimetry, and atomic absorption. An emission will be occurred when the molecule emitted the ray such as flame photometry or fluorometry, and this can be summarized as in this scheme. The electromagnetic spectrum will be contained from many regions such as the X-ray, gamma ray, UV, visible, IR, microwave, and radio electromagnetic. And each one of them have the range from wavelength and occur in many change in its electronic level, and this show in this shape. A UV spectra, it's a matter, and a wavelength for it a range of from 190 to 400 in nanometer. And UV visible spectrum, this region of this range which is shown in this table. Each technician has instrumental in order to measurement the ability of sample to absorb or absorbing or emission for light. UV spectra, its instrumental the spectrophotometer, which contain from source of light in order to give the light or ray, which is undergo to wavelength selector, which is reflected to the sample and then go to the detector, and this detector will have a recorder which is record the absorbs and a wavelength for response this sample. The light which incident for sample will be scattering and reflected in many directions. Incident ray can be called peanut, and the emergent or outside beam for ray can be called or referred to B. The theory of UV spectra depended on idea, which is intensity of ray which is absorbed from the sample. If we suppose I naught as initial or the incident intensity of ray, then the IR can be represented the reflected amount of radiation, will I sub A the amount of light which is absorbed, and the I sub T amount of light which is transmitted from the sample, and the sum of all will be equal to I naught. Absorption law, there are two laws deal with absorption of sample to UV spectra. The first one is Lambert's law and the second Beer law. Let's call them all them linkage in one equation to call Beer-Lambert law, or in some book and literature called Lambert-Beer law. It is the same. Lambert showed that the rate of intensity will be decreased with thickness absorbance, which is proportional of the intensity of incident light. That's mean di over dt equal to ki, which when the I equal to intensity of incident ray of wavelength lambda, and the t represented by a thickness of sample. When take integrating of this equation and putting I equal to I naught, then will be obtained length I naught over IT equal to KT. IT equal to I naught exponential minus KT. When I naught will be represented the intensity of incident light, with IT intensity of transmittance light with K constant, and when convert this equation to natural logarithm sub or dependent on base 10, then IT equal to I sub naught 10 to minus 0.4343 KT, when approximate this number equal to I sub I naught 10 equal 10 to minus KT. The second law will be obtained by or putting by Beer, which show there is the degrees of exponentially of intensity with a degrees of concentration. Then put this equation IT equal to I naught exponential minus KC, and then IT equal to I naught 10 to minus 0.4343 KC, and when approximate this number also equal to I naught 10 to minus KC. And when linkage the equation of Beer and Lambert will be obtained another equation of law called Beer-Lambert law, when equal to then will be obtained log I naught log I naught إلى I equal to epsilon CI, which equal to capital A, when the I naught intensity and I intensity of transmittance والابسلون equal to molar coefficient والC concentration والL pathway or thickness of sample, and capital A represent the absorbance, and when equal the diagram between sample depth or the thickness on x-axis and intensity on the y-axis will be obtain this line or curve, which is depend on inversible relationship between them. The principle of UV spectra absorption depending on electronic transition between level of atom or atomic orbital. For example, the level N, pi or L sigma, and this can be depended for absorbing more amount of wavelength. This called lambda max. Also the large value of intensity or the maximum absorption called E max. In general, the UV spectrum depended on two factors: the solvent and concentration of solution. This type of transition can be divided into four. The first is sigma to sigma star, such as in methane, and this type of transition will be on a pure and saturated compound, and this is the wavelength for it will end to sigma star, also unsaturated compound which contain heteroatom carried at least one pair electron, such as oxygen or nitrogen. The pure transition N to pi star and for pi to pi star, always the range of this transition between 200 to 700 nanometer can be represented by this diagram. This is the atomic orbital which occupied with electron, N will pi will sigma, and the sigma star will pi star which unoccupied level with electron. This diagram classify the orbital and show the difference in energy between a transition. For example, an N to pi star, this is the energy. In N to sigma star, more than in energy for an N to pi star. Also, pi to pi star, this is the energy of transition pi to pi star, and the energy of the sigma to sigma star, it is very larger than pi to pi star, and the orbital which occupied with electron called the bonding orbital, such as pi with sigma, and N level non-bonding, as you know in organic chemistry, and the anti-bonding which represented by pi star and sigma star. The electronic spectra can be represented by absorbance and a wavelength in order to obtain this shape of curve of UV spectra when we draw the relationship between the wavelength and x-axis and the absorbance from on the y-axis. This is the UV spectrum of acetone, and this shade will be appear with this is the wavelength nanometer, and this is the absorbance. And the lambda max adds more absorbance called lambda max, which is wavelength at maximum absorbance called lambda max. The type of transition can be divided into allowed transition, such as pi to pi star transition. This type of transition when the coefficient molar absorption was more than 10 to 4. This is in many compounds such as 1,3-butadiene when the distinction coefficient is more than 21,000. The second type, the forbidden transition, and this type will be obtained in compound when molar distinction coefficient is lower than 10 to 4, and this occurs in anti-bonding orbital such as pi ستار. شكرا لإصغائكم، إن شاء الله المحاضرة اللي